Okay, hello and welcome to my laboratory 6. So here for the laboratory 6, we have these three objectives, which is create new project in PI, use follow to execute codes repeatedly, and modify the block diagram based on the loop conditions. Okay, so for step 1, we follow this block diagram. So let's add them. Okay. We need okay again this here. So of 3006. Okay, that's 3000. That's 6000. That's 3600. So we get this. So 3600. Okay. And the answer of that. Okay. So the quotient will be ours and the remainder will be divided again. Uh, excuse me. Okay, so we will have another remainder quotient. Okay. So having this, the remainder will be connected to the remainder of the other one, and there will be a constant of 60. So okay, right here. So and let's have an indicator. So here total time seconds. So let's do that. Total time seconds. This should be hours. Okay, so with here and the quotient will be minutes. So create minutes here, and the remainder will be in seconds. Okay, so we managed to get the same block diagram in panel. So run this several times with the different values all the time seconds. So let's do that. So first let's save this. Let me just save this so that when it crash, you will be able to recover. And oops. Okay, that's good. So let's try 70 and let's run it. 70 is 1 minute and 10 seconds. 360. Let's run it. That is 6 minutes. Because 6 times 6 is 36, so that's why we have 6 minutes. And let's have 3000. Let's see. 3750. Let's try that. Okay. Run. So that is 1 hour, 2 minutes, and 30 seconds. Okay. But if you want to put it all at once, okay. So for this step 3, the instruction is to add a while loop statement. So structure while loop and let's close it right here. and I believe we can create a control right here. Stop. And okay, so this list the functions of the numbered item in the figure. So this is a stop button, current iteration. I think this is just a indicator, I believe. This file is different, but it looks like an indicator. So what about iterations? So let's try on this. So I think again and this one, this plus. So as you can see, I just press run and it will not stop till I press the stop on. So I think that's it. So this is the stop control, and this is a digital what do you call this numeric indicator for the current iteration. So current iteration. So let me just edit that. So current iteration. So for now we are at how many? I think this one is 4 million, I believe. So let's see, 724, 43,579,724. So that's it. And this I right here shows the loop iterations. As you can see, the loop iteration, it's just connected to a numerical indicator, and this stop right here, loop condition stop, this is connected to a control for the stop. So that is for the question 3.1. So I will type it later. Okay, so update the front panel. Switch to the front panel. Organize the front panel shown in the front figure. So you can do that. So it's okay. So you just need to move this one. Okay. And this stop right here. You can see that. Okay, so we are done with step 4. Okay, step 5. Increase the significant digits of the current indication. So right click the find iteration indicator and select display format. Okay, so let's do that. Right click, display format, safety, properties. So okay, we go to right click, properties, display format. Let's put into decimal, I believe. It says decimal. And under the type section. Okay, so let's do that. Okay, we're done with step 5. So now it's step 6. Run the VIG to value TTS total times and cents. Let's hold into value so the R's may indicators assuming are continuously updated. Most current iteration indicator is implementing. Okay, so let's try that. So let's run this. Okay, so if I make this 20, just 20 seconds. So here's the total time seconds control. Okay, notice that the vehicle is sila in the while loop, so ours. Okay, notice that the current iteration is 20, so you can see that. Because we're not 68, 69. Yeah. Click stop button to stop the stop time. And Control T. Turn on execution lighting by clicking the highlight execution button. So I believe that is in the tools. Execution. Oh no, it's right here. I think it's this one. Highlight execution. Okay. And the back line now notice the code. Let us see that execution. Click stop on it. Okay, so you can do that. Okay, let's run. So as you can see, we are currently iteration 1 and it shows what it is doing slowly. So let's make it to 202. So add, it's a bit messy because of my computer graphics, but okay. Oh, yeah, there. So add around 8 iterations. So you see there's a bit of pulses. So the bit right here is the same. Okay, so this one travels almost exactly the same. Mission follows here, and for every start, it also checks if the stop button is pressed. So, okay, please. So, okay, we perform that. Let's press stop. So at the, I believe, 20th iteration, we will stop, or 19th, because right before the iteration, 20th operation starts, it receives a stop signal, so that's why the code stop. Okay, so we are that's good. Okay, for step 8, click highlight execution again to receive execution to save the VI. So let's save and let's try run this one. So as you can see, it is very fast. Okay, we can stop it right now. And that is for the first part. So now we go for the part 2. Okay, for the part 2, count the total number of iterations. And output that I divided these functions of the number of attempts in the figures. So plus 1. Uh, there's plus 1. Okay, so because the while loop starts at 0, so in order to count 0, as first iteration, we add 1. So 0, 0th iteration is our first iteration. So I have an additional plus 1. So let's do that. So let's add numeric plus 1, numeric plus 1, numeric plus 1, increment. There. And let's connect this wire outside. And let's create an indicator outside. So total iterations. So let's do that. Okay. Iterations. Okay, we can add it right here. Just right beside. Okay. So this one is the increment plus one function. This is a control signal indicator, numeric indicator, and this is just the counter of the while loop. So step 9. I will answer that later when we finish everything. So just says that we need to adjust things. Okay, so we perform step 9. For step 10, select the total indicator and convenient display, but there is no display on my screen. Okay, as you did with the current indication indicator. So we just right click this one, properties, display format, we go to the SM1 and press OK. Okay, so we perform step 10, question 3.3. Run the VI, notice that the iteration is not updating. Click stop button. Notice that the iteration now updates. What is the reason for this? Use the okay. So we can do that. So let's run. So it clearly shows that the total iterations outside the value does not continue or does not operate because the condition inside our while block or while structure is not met in order for it to stop. So it is continuously iterating. So until we press the stop button, that is the time where we will receive a number on our total iterations. So anything that is connected outside the structure, rather the loop structure, it will need to wait to finish the operation inside the loop structure before performing the operations connected outside the structure. So that is my answer for 3.3, and I will write that later right here. Okay, okay, step 11. Make the higher execution, run the VI again. Okay, So it just says that we click the highlight and let's perform it again. Let's run. So as you can see, it sends the data to the total iteration so that when the while structure is the loop structure condition is met, it it will be ready to perform the increment one and display on the numeric indicator. Okay, so that is what's happening. And the flow of data, of course, as you see, the total nine, the operation right here is almost in sync. So for all the constants, all the constants and this one, they all go inside the remainder quotient function at the same time for the as well as the input. So with a bit of delay when displaying the when passing through a computed value. So right here there's a bit of delay from this one to this one. Okay, and same to yeah. Okay, that's good. Let me just stop it right here. Press the stop button. So, and if I stop, it will wait for everything to finish. And total iterations 80. So because again it uses the the number 0 as our first iteration, so that's why okay. So let's go back to our next step, which is part 3. Okay, so step 13, drag the time seconds in out of the while so that your okay, so it just says that this drag is outside, so let's do that. Okay, and let me just unclick this one. I think it's bug. Okay. Then separately, I believe it will ask what will happen. Press Ctrl T, turn on the execution highlighting, and watch the block diagram and what will happen. So let's see. Let's first just save it. So let's run. So let's change this one to 100. Okay. Where is my mouse? There. Let's change this to 100. So as you can see, okay. So it receives the input 100 outside the while loop. So let's make it, let's increase it to 120 so that we will get exactly 2 minutes. So with that said, since we are first operating the input right here, since the input is not is an independent component, it can already provide the signal to our while loop, while this one right here is a dependent function. So in order for them to operate, an input must be fed to them. So that's why right here we are now currently stuck inside the while loop. Yes, the loop structure, because our input right here is outside the while structure, so there's no way of changing this one once we already hit the start button, and for whatever value that we first entered, it will continuously work on that. So 1 minute and 40 seconds is total time seconds of 100. So as you can see, we are now at 125, so the answer should be is 2 minutes and 5 seconds. But as you can see, it does not change. It does not change the output of our hours, minutes, and seconds. So that's the difference of the numeric control inside the loop structure and outside the loop structure. So let's go to question 3.14. So what is the return value of the input panel? I already answered this one as I said earlier, because of the place of the numeric control outside the loop structure. It only returns it only uses the very first value that we entered, since there's no way of repeating the repetition of reading the input signal from the numeric indicator. Okay, so I will answer that later. Actually, I will type the answer later. So move the total 10 seconds and its current wait. Move the total seconds control back to the values as shown in front mirror so that the value is the right value to control during every iteration. So this one already answered the question of 3.4. So if we return this back, so let's press stop. Okay, there. So let's move this back in. Okay, let's run. So 135, 139. There, as you see, 2 minutes 9 seconds. Let's make it exactly 2 minutes. And 2 minutes, exactly 2 minutes. Okay. So okay. Move the total sign so that the y value reads. So I think this is just an instruction, not an actual question. Because there's no question right here. So move the total time seconds control back into the value that should be here. But again, this one already answered the question. So if we enter the numeric indicator inside the while loop, it will continuously ask or it will continuously read the value of the numeric indicator, numeric control rather. Say the VI and the project. So let's stop this one. Let's wait for it to stop. Uh, there. Okay, let's save the project. And I believe we are done with our laboratory 6. So since we completed part 1, part 2, part 3, and the rest for me is to answer all of the text submission inside this laboratory manuals right here, and to generate a laboratory report, and of course submit this video. And so that's it for me for the laboratory 6. So my name is Carlos Castillo, and thank you for watching.